Okay, I wanted to make this video because I wanted to talk a little bit about what's in section 3.5. So section 3.5 in your textbook talks about, well, first off, we've been graphing quadratic equations. And so far, what we have dealt with is we have dealt with equations that are in this form. The reason we want it in this form, we call this standard form. And the reason why we want this in standard form is because we can get a picture of what the quadratic looks like without actually having to do a table of values or anything like that. For instance, we know that the P tells us whether the parabola has moved left or right. We know that the Q tells us about up and down. We know that if the A is positive, it's opening up. We know if the A is negative, it's opening downward. We know that the vertex is P and Q. We can get all kinds of information when we have an equation in this form, in standard form. However, many times in math, they don't give you things in standard form. They actually give you an equation in general form. And an equation in general form would look like this. So that would be something like y is equal to 3x squared plus 4x minus 7 or something. This is in general form. The problem with general form is you can't get information. Oh, sorry about that. Wicket, no. You can't get information off of it in order to make your picture. You can't get the vertex. You can't tell whether it's skinny or fat. You can't tell whether it opens up or down. You can't get any information on that. So what you really want to be able to do if you have something in general form is convert it or change it into standard form. So I'm sorry if you're hearing growling, that is the dogs. For example, they give you an equation of y is equal to, just a sec. Let me just try a different thing here. Let's try this one. Okay. They give you an equation of y is equal to x squared. Nope, it still doesn't want to work there. Never mind. Something up with my screen there. I'm going to just go back to the darker one. And I'll go over here. Y is equal to x squared plus, why does it have these dead spots? 6x plus 8. So let me write that down here. Y is equal to x squared plus 6x plus 8. That is in general form. It's in general form because it's got that ax squared plus bx plus c thing. They ask us to sketch the graph, find any intercepts. Well, I can't sketch the graph when it's in this form. I need it in standard form. In order to get it into standard form, I need a trinomial that will factor, that will break down into something like x minus p squared, like x minus 3, let's say, squared, so that this is x minus 3 and x minus 3. You need something that will break down. So for instance, if instead of this you had x squared plus 6x plus 9, that would actually break down to x plus 3 and x plus 3, which is x plus 3 squared, which is what this is, x plus or minus something squared. You need it, but that's not what we have. We have x squared plus 6x plus 8. We don't have x squared plus 6x plus 9. So what we need to do is to create somehow a perfect square trinomial. In order to do that, what you have to do is this process called completing the square. And it really is a step-by-step thing. It's just what you do, all right? So the first step is that you're going to gather anything that has an x together, leave a space, and put the constant off to the side, because we're going to forget about that constant for a minute. Now, we're going to do this process called completing the square. Just a second. So the reason why we complete the square is so that we have something, we'll have a trinomial that breaks down. Just a minute, she's still whining. Okay, I think the dogs have calmed down a little bit. All right, so in order to complete the square, what you have to do, and this is just the steps every time, you take the number in front of the x. In this case, it's a 6. Divide that number by 2. So 6 divided by 2 is 3. Square it. 3 squared is 9. So we're going to add 9 to this wonderful equation. But I told you can't do something to one side and not do it to the other, right? Because that will change the value of the whole thing. Well, adding 9 to this side would be awkward. So because there's just a y over there. So rather than do that, we add 9, but we also subtract 9. Because 9 take away 9 is nothing. It's 0. So while we've done something, we've added 9, we basically, in a way, undo it by subtracting the 9 so that it doesn't change the value. Now, why do we do that? That seems weird. The reason why we do that is because that creates this perfect square trinomial. It creates a trinomial that breaks down. If you factor this, it breaks down to x plus 3 and x plus 3. In other words, x plus 3 squared. Whenever you complete the square, it always creates a perfect square trinomial. So the good news about that is you don't really have to work very hard to factor it. If you know it's a perfect square trinomial, all you have to do to factor it is what two things multiply together to give me x squared, x and x. What two things multiply together to give me 3 times 3. And 3 plus 3 makes 6. It makes that middle. Take the square root of this number and the square root of that 9. How do I know whether to put a plus or a minus in the bracket? Look at this sign right here. If it's a plus, you put a plus. If it's a minus, you put a minus. Now, I still have the negative 9 and the plus 8 I haven't done anything with. So combine those. Negative 9 plus 8 is minus 1. So my equation is y is equal to x plus 3 squared minus 1. So if they ask me to graph that, I know that the x plus 3 moves it to the left 3, 1, 2, 3, and I know that it moves it down 1. So I would end up with a vertex. I would end up with a vertex at negative 3 and 1. There's no number out in front, so that means it's not skinny or fat. It's just a regular size. And it's positive. There's no negative, so I know it opens up. So I know my parabola is going to look something like that. So I have a sketch. Now they want to know about the intercepts. If you have, negative 3 and negative 1, my apologies. If they want to know the intercepts, if you've graphed it carefully, you can get your intercepts right off of your graph. But if you're like me and you've just sketched it, you need to find your intercepts. To find your intercepts, just hold on, I'm going to give myself some space. To find your intercepts, you're going to take the equation that you just found, which is x plus 3 squared minus 1. And you're going to say, okay, for my intercepts, for this one and for this one, my y is 0. When you have x intercepts, your y is always 0. For x intercepts, your y is always 0 because you're going across your x-axis to get to them, but you're not going up and down any. So I'm going to take the equation that I have, y is equal to x plus 3 squared minus 1, and I'm going to put 0 in for my y. So x plus 3 squared minus 1. So I put 0 in for my y. I'm going to move my 1 over. So I have 1, and here's that dead spot. 1 is equal to x plus 3 squared. And then I'm going to take the square root of this side so that I don't have x plus 3 squared, I just have x plus 3. But that means I have to take the square root of this side. The square root of 1 could be positive 1, but it could also be negative 1. So remember, I want to figure out what x is, so I'm going to move my 3 over here, which is going to give me negative 3. So negative 3 plus 1 would be negative 2. So one of my x-intercepts is at negative 2 and 0, which sort of makes sense with my equation. So negative 2 and 0. And if it's negative 3 take away 1, then my x is negative 4, which makes sense. Let's say 1, 2, 3, 4, right there. So also that makes sense, negative 4 and 0. Now, if I need a y-intercept, so negative 4 and 0 and negative 2 and 0. When I have a y-intercept, my x is always 0. When I'm trying to figure out a y-intercept, my x is always 0. So I'm going to take that equation again. Y is equal to x plus 3 squared minus 1. But this time my x is 0. So y is equal to 0 plus 3 squared minus 1. There's that dead spot again. And if I work that out, 0 plus 3 is 3. 3 squared is 9. And 9 take away 1 is 8. So I end up with y is equal to 8. All right? So that is completing the square. We're going to do another one. That was example 1 on page 127. I'm going to also do example 2 on page 128 because this gets a little bit more complicated, as if that wasn't complicated enough. They say express y is equal to 3x squared minus 12x plus 11. That's in general form. They want us to put it in standard form, then sketch the graph and find any max or mins. Well, remember, a maximum or minimum always happens at the vertex. So basically, they want us to find the vertex. So I have to complete the square. So remember, I said the first thing that you're going to do is gather your x's together. And that constant, we're just going to sort of ignore. There's a problem with this, though. In the last one, there was not a number in front of the x squared, and this time there is. You cannot complete the square when there's a coefficient, when there's a number in front of the x squared. You cannot complete the square. So what you have to do is you have to take that 3 out as a common factor. Now you're going to take it out of anything that has an x. So you're going to take it out of these two places. And there's that dead spot again. Let me go down here. There's a squared there. You just don't know it. Okay. And then I still have that plus 11. I didn't take it out of the 11. I only took the 3 out of the pieces that have the x. Okay. So, no, go. Sorry, dog climbing on me. Once you've taken out that common factor, once you've taken that 3 out of there, you can now complete the square. So once again, to complete the square, we take the number in front of the x, which is 4. We divide it by 2. 4 divided by 2 is 2. And then we take that answer and we square it. So 2 squared would be 4. We add 4 and we subtract 4. What's important is that that is all inside brackets with the 3 in front of it, because you completed the square after you took the 3 out, so that the plus 4 and minus 4 have to be where the 3 is. Now I'm going to factor this perfect square trinomial that I just made. Remember, when you complete the square, it makes a perfect square trinomial. So when I factor that, the square root of x squared is x, the square root of 4 is 2, and there's a minus here, so it's x minus 2 squared. The thing is, I didn't do anything with that minus 4. It is still here. So I factored the trinomial, the minus 4 is still here, and hey, that plus 11 is still stuck on to the end. Now, I need to get rid of this 3 out in front in a way. I need to expand it out. So just look over here for a second. If you had 3 times x plus 4, Wicket, no. You would do the distributive property. You would go 3 times x is 3x, and you would go 3 times 4 is 12. You would multiply both pieces by the 3. The same rule applies here, but you have an x minus 2 squared, that's one piece, and you have the negative 4, that's another piece. So just like up here, when you multiply 3 with x, you don't really do anything, you just write 3x. When you multiply 3 with x minus 2 squared, you don't really do anything, you just put the 3 out in front. But then when I multiplied the 3 with the 4, I got 12. So same thing. If I multiply the 3 with the negative 4, I get negative 12. And then I still have that plus 11. So now I have 2 constants that I could put together. Y would be 3 times x minus 2 squared, and negative 12 plus 11 would be negative 1. So now, if they ask me, which they did, if they ask me to sketch this, and again, just a sketch, I'm just giving a really rough sketch here. If they asked me to sketch this, and I'm going to try and go somewhere where there isn't, oh, nope, there's a dead piece there. I don't know why. What if because I tried it earlier and there was no dead space even if, look, it's like nothing. Okay, so where are all my dead spaces? My dead space is there. And I seem to have another one right there. Interesting. I'm just trying to find them, sorry. Rabbit trail. Okay, so if they asked me to draw this, which they did, just a sketch though. If they asked me to sketch this, I'll go down here. My vertex would be 2 and negative 1. So to the right 2, down 1. 1, 2, down 1. The 3 is positive, which means it's opening upward. but it's a 3, which means it's 3 times skinnier, which means this is a bad parabola, I apologize, but it's very skinny. Okay, so again, that's just a rough sketch. I put the vertex in the right place, but other than that, all right. I'm going to do one more example this evening, and then I'm going to call it quits. So, what's this one? Ooh, very bold. So the next one adds another level of difficulty into it, but if you have a calculator, it's not that bad. So, and I'm going to rearrange this. Example 3 on page 128 gives y is equal to negative 3x squared plus 5x. And they want me to complete the square with this. Okay? So again, you cannot complete the square when there is, okay, so there's no constant to move over to the side, first of all. There's no constant to move over to the side. That's good. But the number in front of the x squared is a negative 3. I'm going to go over here because I think that's below my lovely little dead space. I have to take the negative 3 out. I was wrong. It's not. Okay. I have to take the negative 3 out. So when I take a negative 3 out of here, I end up with x squared. But if I take a negative 3 out of here, I end up with minus 5 over 3x. Well, that's disgusting. I now have to complete the square with a fraction. So that's why we have a calculator. So I take 5 over 3 and I divide it by 2, which gives me 5 over 6. And then I square it, which gives me 25 over 36. So let me say that again. In order to complete the square, same process, it doesn't change just because it's a fraction. Take 5 over 3, divide it by 2. That gives you 5 over 6. Square it. That gives you 25 over 36. So I'm going to add 25 over 36, and I'm going to subtract 25 over 36. So now this is automatically a perfect square trinomial. It's automatically a perfect square trinomial. But, just let me see. It's funny, it's not a dead space when it's my finger. So if I'm going to factor this, again, the square root of x squared is x. There's a minus here, so I'm going to put a minus. The square root of 25 over 36. Just take the square root of the top and the square root of the bottom. The square root of 25 is 5. The square root of 36 is 6. So it's x minus 5 over 6 squared, and then I have minus 25 over 36. The negative 3 is in front of the whole thing. Okay, so same as before. I'm going to take this negative 3 and I'm going to multiply it with the x minus 5 over 6 squared. That is simply negative 3 times x minus 5 over 6 squared. You don't do anything with it. But I also have to multiply the negative 3 with the negative 25 over 36. Use your calculator. Negative 3 times negative 25 over 36 should give you a positive 25 over 12. So as disgusting as that is, it's now in standard form. So if they ask you what your vertex is, which they did, they ask you what your vertex is 5 over 6, because whatever your p is, that's the x value. Remember to change the sign when you take it out of brackets. And the y value, or the q value, is 25 over 12. So if they asked you to graph this, which would be gross, but it would just be a sketch. 5 over 6 is almost 1. So we're over almost 1 square. And 25 over 12 is like 2 and a little bit. So we're over almost 1 and up 1, 2, and just ever so slightly more. It keeps wanting to. So right there. Right there, right there, right there. Now, notice there's a -3 out in front. The -3 means it's opening upside down. And 3 means it's 3 times skinnier than a regular parabola. So it's going to be fairly skinny. So it's going to look like that. So that is the basics of completing the square. We started with an easy one and we went to a harder one. All right, and that's it.